today is square root functions. The simple square root functions is y equal square root of x. And today I will go into analyze and represent graphically the function y equal square root x, the square root functions. And I will name this simple function as a parent functions. Before to create a graph, before to graph these functions, it's very important find what is the domain of these functions. The domain of these functions is all values greater than 0, because the square root of the negative number is not defined in the real set. And because the x always is positive, the square root of this number is positive, then the range of the square root parent function is all the values greater than 0. To make a graph, I'm going to use this table. I use 0, I select 3 numbers less than 0, and I select 4 numbers greater than 0. And that's very important. In this case, I use some number when I can find exactly square root. It's evident because if you use -9 is undefined because the domain is positive. -4 is the same undefined because it's negative, and the domain is all the number greater than 0. But the square root 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And the square root 16 is 4. Now, if you use now the coordinate system, you plug in each value and you make a graph of the square root parent functions. Now, I'm going to multiply the parent functions by a number 8, and I have the domains continue be the numbers greater than 0, because it's the same case of the example before. The possible value to x have to be positive. But in this case, the range changed according to the value of the a. If a is positive, the function is positive. But if the value of the a is negative, because the square root of the number is positive and multiplied by the negative number is negative. Now, the range of this particular square root function is, if the value of the a is positive, the range is all the numbers greater than 0. But if the value of the a is negative, the range of the function is all the value less than 0. And I use in this example a equal 2 is positive. Now I select the same table. In the -9 is undefined, and the -4 is undefined, and the -1 is undefined. Now, when you use 0, like this, 0, the square root in the parent function here is 0. And when you multiply by 2 is 0. 2 times 0 is 0. When you select 1, the square root of 1 is 1, but you multiply by 2 because a is 2, and you continue to another value. The square root 4 is 2, and 2 times 2 is 4. The square root 9 is 3, and you multiply by 2 is 6. I multiply by 2 because a is 2, and this is the value here. Then the square root 16 is 4, and when you multiply it's 8. In the coordinate system, you make a graph. The red graph is the parent function. This is the parent function. This is the parent function. In this example, because a is 2, this is the graph of the function 2 times square root x, 2 times the parent function. We'll see in another example what happened when the value of the a is negative. Another example. Now I'm going to introduce inside of the square, subtract a number h. Now the domain now, remember, all of these number, all completed these had to be greater than 0. When this is greater than 0, when the value of the x is greater than h. When the x is greater than equal h is when this function is greater than 0. So you write x minus h greater than equal 0. And when you solve this equation, is x greater than equal h. And now this is the domain. And the range is the same situation to the exercise before, to the example before. If a is positive, y, the range is greater than all the value greater than 0. But when the a is negative, is the value of the range is all the number less than equal 0. You create a table. In this case, I'm going to use h1. You plug in on the table. Your value is negative 9. Minus 1 is negative 10. This is undefined here and undefined. And when you use 0, 0 minus 1, because h is 1, is negative 1, and the square root of negative 1 is undefined. When you use 1, here the value of the x is 1, 1 minus value of the h is 1, is 0. The square root of 0 is 0, and when you multiply by 2 is 0. If you use 4, 4 minus 1 is 3. The square root of 3 is 1.73, and when you multiply by 2 is 346. And you do with the same, continue doing with the same value of the x. And when you represent, in this case, that's my example, 2. This is my example. Then, now, when you make a graph, I have the red is the parent function, the blue is the exercise before, and the purple is this function. You see, pay attention now, because I have this example in the problem before to this problem. What I'm doing now, I move the blue line 1 unit to the right. Then this is 1 unit here to the right. Then I move 1 unit to the right. I'm going to do the conclusion at the end of these examples. Now, I add now another value here in my problem. What I do now? I increase the value of k. The domain is the value of h greater than h. It is here, greater than h. And now, what is the range? The range is when a is positive, the range is all the value of the y greater than this value of k. And when the value of the a is negative, the range is all the number less than equal k. In my example, I'm going to use a equal 2, h equal 1, and k equal 2. You create a table. When I make a graph, is here. Now, you see now in this example, the function in green is the new function in my problem. Now, if you see this green function, this one, I select this one, the exercise before, and I move 1 and 2 units up. Okay? These 2 units up corresponding to the value of k, and the k is 2. Now, I'm going to do now the conclusions about this topic, and when I finish this, I'm going to show you using demos software what happens when you increase, when you change age and case, when you change a. I'm going to show you using demos many examples. The domain, this is the general square root function. The domain is the solution of the equation x minus k, x minus h greater than 0. And the domain, the range is, if a is positive, y all the value greater than equal k. But if a is negative, all the value less than equal k. The model function, the final transformation, and this is the image more important to solve and to represent graphically any root, any square root functions. When a is greater than 0, you move the model function or the parent function, you move to the right. When h is 0, when h is less than 0, you move to the left. When k is positive, you move it up, and when k is negative, you move it down. When a is less than 0, it's a stretch, it's a vertical stretch. And when a is greater than 0, it's a vertical compression. Now, I'm going to do now to show you in the Desmos software, this is the domain of the parent, this is the parent function. What is the parent function? Square root of x. This is the parent function. Now, I'm going to show you now what happened with the transformation. Remember, the red line, the red graph is the parent function. Then I'm going to do some transformations. For example, what happened if a is, for example, if a is negative 2? Well, in this case, a is negative 2, h is 0, k is 0. What is the graph? What happened? The function now is negative. Remember, when the a is negative, the range of the parent function is negative value. Okay? This same function, I'm gonna change now h. Suppose that h is k is, for example, 2. What happened? I move 2 units to the right. But if this h, for example, if a is negative 2, I move 2 units to the left. Okay? What happened now if a is positive? I'm going to change now a is positive, 2 positive. Is the function is positive, but I move the function 2 units right. Then, now, I'm going to change another parameter. For example, this function, a is 2 positive. If a is positive, the range is positive number. And now he moved 2 units left because a is negative. Now I'm going to change k. And I'm going to change k, for example, 2. Hey, what happened? The function moved 2 units up. Okay? Now, I'm going to do another example. What happened when a is not 2? Suppose that a now is 0.5. Okay, it's a compression. Let me change here, and I'm going to use 0, 0 here. I'm going to use 0, 0. Now, I have now the function y equals square root x, but I use a A 0.5. You see the graph has a vertical compress, but if A is greater than 0.3 is stretch. Let A, when A is between 0 and 1, for example, 0.5, it is compressed. When it's greater than 1, it is stretch. Okay, and I move, for example, I've changed H to 2 to the right. If I move negative 2, 2 to the left. But now, if I have here, for example, 0, and I move K, 2 unit, move up. But if this value of K is negative 2, he moves down. Okay, now, using this software, you can create a graph that can help you to do the exercise. Thank you very much to watch this video, and I will see you in another class. Thank you very much.